Okay, so can somebody give me a quick 1-minute summary of what took place at Toyota? How did they implement, or why did they implement concurrent engineering? Anyone? Come on. Okay, so Toyota was one of the first companies in the entire world to implement something called concurrent engineering. So what concurrent engineering is, like we talked about last week, well, actually, what is it? What is concurrent engineering? We talked about it last week.
Engineering, where all the departments are being simultaneously rather than step by step.
Okay, so what's the advantage of that?
Everybody's involved in the design.
Okay.
And everything considered. And bottlenecks are reduced.
Okay, so how did that help Toyota? Okay, what else?
The product development cycle was reduced.
Okay, how so? So they talked about some of their competitors and the process their competitors followed. So what was the difference between what Toyota was doing versus what their competitors were doing?
The competitors were
Okay,
longer time making decision.
right?
But at the end of the day, they actually brought out something more better quality as far as customer demand and on time, unlike their competitors who maybe did the
Serial engineering, and they just produced a product. Right. So using the concurrent engineering, what Toyota did was they spent a lot more time in the planning phase of their overall product, and they spent less time in the manufacturing, etc., because they were able to get their product to market a lot faster compared to their competitors. But one of the biggest things is, although Toyota is spending a lot of time in that planning phase, it keeps going back and brainstorming ideas, keeps reviewing those ideas, building upon previous ones, etc. It also led to a product that was more likely to satisfy its customer needs than its competitors' products. As a result, Toyota in general ended up having a better product. It was also because of the processes it followed, because it spent a lot of time thinking its solution through right at the beginning. It was able to make its operations a lot more efficient. Okay. What about the fourth question? So do you think that the same model can be applied to other industries, and has anyone actually seen it in their area of work, concurrent engineering? Okay, G. So what does G do out in the case study?
with regard to the aircraft.
Okay.
Google,
Yeah.
they have in their design base, they don't just have computer scientists, they have psychologists, they have teachers, they have mathematicians, they
Right.
have everybody in the design base for a software problem. And because of that sort of networking they have,
So how do you think that actually benefits them?
the input they have from every department, and like how much different expertise in every department can affect the product. We only get engineers that need the product and design phase, and they only do that perspective, and they wouldn't have any solution for a problem they didn't think of. Whereas people from different backgrounds can come up with different problems that the product is solving.
That's true. Okay, so that you're completely right on that. Also, bringing people from different backgrounds to the table helps to, if you have a certain problem that you're trying to solve, brings different perspectives to it, which helps come up with new and better solutions, which can overall improve the quality of what is actually being produced. So, do you find your example?
Yes.
other companies that may use concurrent engineering, maybe from where you've worked before? Okay, so then you would have the people working on it in the next phase would sit with everyone so they understand what's going on. Okay, good. Okay, so how did Toyota actually benefit from here? So we talked about lead time. So they're able to get a product to market faster. How else did it help or did it benefit the company? Guys, you need to know this for the exam next week for those who are writing, so participating would be strongly suggested.
Since the department factoring more requirements, and definitely the product that is good with the customer expectations better than
Okay, so it's more like, so you think it helps to increase the value of it? Okay. Okay, so what changes took place at Toyota and why? One of the discussion points that came up in my Friday class was Toyota was able to implement concurrent engineering more so because of the region in which Toyota is based, because Toyota is a Japanese company as opposed to an American company, so they're more easily able to implement concurrent engineering. Anyone have any thoughts on why? So, based on a discussion point that came up in my Friday class, they felt that Toyota was able to implement concurrent engineering more easily compared to other companies that would try to implement concurrent engineering because it was a Japanese company and it was based in Japan. Do you guys agree, or do you guys have any thoughts on why that's the case?
Asian culture is more, in a way, disciplined than American
Okay.
It's also in Japan the same thing with the manufacturing. So in Japan they don't have the flower area, so they have those hands-on in a regular place. Secondly, they're more social and they get to like discuss.
They start discussing the problem a lot more readily than, let's say, American culture.
Yeah.
So you're right. So all of this, in the end, and I know this is off topic from systems engineering, but in general, it's a big management topic, which is organizational behavior and culture, and how all of that relates to the different decisions and the way we do business. And it actually very heavily influences how things work and the likelihood of success. So again, it's because, like you said, Japanese people, or just like the Asian culture in general, is a lot more disciplined compared to maybe a Western culture, because they're more social compared to, not that we aren't social, but when there's problems, etc., they're more social about it, and they're looking for ways to solve it. And all of those things together helps to determine how successfully certain things such as concurrent engineering or even other types of processes, etc., can be implemented within an organization and how well they actually work. Okay. Does anyone have any other questions based on the case study, or have any comments to make about the case study?
I have a question. From the use case that we have, it seems it's only applicable in manufacturing product construction. Is that so?
very applicable in other industries too. So it's currently being used quite a bit, especially in the telecom industry now. So when people, or when you're developing telecom systems, very expensive systems, you want to get them right the first time.
Well, that's how the manufacturers think from.
No, but even like the software that goes into the telecom systems. So all of this concurrent engineering, right? Like re-engineering helps you get a product, if implemented properly, will help you get a product to market faster. You want to get a product to market before it becomes obsolete. So one of the reasons why it's used very heavily in the telecom industry, or even the software engineering industry, is to help get a product to market faster. So when you're talking about telecom, so let's say companies like Ericsson, Ciena, etc. So they start, when they're developing their software, instead of just getting this, the various developers or the different functional leads to start working on the various components of their software and then integrating it all together, they start working on it together right away. So they follow a concurrent engineering process. They all try to understand how things have to integrate together afterwards, so that they're able to, improve their design and design their product or their component in such a way that it'll integrate well later on. So overall, it helps to, build that better product. So it's actually being used in a lot of companies here in Ottawa today. Not just Ottawa, even all over the States and stuff. Yeah. Any other questions on concurrent engineering? Okay, you guys are quiet class, so that's it. So I will see some of you next week.